All right, welcome to Mr. Baker's House of Knowledge. Here we have two triangles, and I can actually claim that these two triangles are congruent. I can claim that triangle ABC is congruent to triangle DEF. Does anybody know what justification I use to claim that those two triangles are congruent? Yes, sir.
Angle, side.
Right. Angle, side is the reason why those two triangles are congruent. So I have two angles congruent to two other angles. I have a non-included side congruent to a non-included side. These sides correspond because both of these sides touch the angle that has one arc mark on it. So when I wrote my triangle congruency statement, I made sure A matched up with D. I made sure that B matched up with E, because that's the one that didn't have any arc marks on it. And I made sure C matched up with F, because that's the one that had two arc marks on it. And AB matched up with DE. Now, what does it mean to be a congruent triangle? Well, to be a congruent triangle means that all of your sides and all of your angles are congruent. So once I've written a statement that proves that the two triangles are congruent, and I needed three pieces of information to do that, I now actually have three other pieces of information. Because the two triangles are now congruent triangles, and I did not use this stuff in red to prove the triangle's congruent, but I now know it's true based on the aftermath of having congruent triangles. I now know the three pieces of information in red. If I wanted to include a statement in a proof to now say that angle B is congruent to angle E, I could, because now that's actual factual information. Or if I wanted to say side AC is now congruent to side DF, I could do that now because that's actual factual information. These two things are true by a concept known as CPCTC, and that stands for corresponding parts of congruent triangles are congruent. So we need to know that. Corresponding parts of congruent triangles are congruent. So we have this statement, corresponding parts of congruent triangles are congruent. What that means is if I can prove somehow that two triangles are congruent, then all parts of the corresponding triangles must be congruent. And so a lot of times we'll prove the triangle's congruent using three pieces of information, and then we'll extract a separate fourth piece of information out of that to make another statement to prove, and we use the corresponding parts of congruent triangles to do that. So that leads us with a reason, and the reason is going to be CPCTC, corresponding parts of congruent triangles are congruent. That's probably a good one to make a note card on. Now, the other day we talked about the 5 ways to prove triangles congruent. CPCTC is not one of the ways to prove triangles congruent. You must have already proved triangles congruent to use this reason. Okay, so let's see what I'm talking about here. So I'm going to give you an example of a proof. So the proof starts out with proving parts of triangles congruent. We're given that KBC is congruent to angle ACB. So KBC, this angle down here is congruent to ACB. ACB is this angle up here, and they're already marked. And angle K is congruent to angle A. So they're already marked on the drawing, the given information. Now my ultimate goal here is to go and to prove that this line right here is congruent to this line right here. Well, if only I knew that the two triangles were congruent, then I could say that those lines were also congruent because corresponding parts of congruent triangles are congruent. So that's how I'm going to approach this proof. I'm going to look for ways to prove that the two triangles are congruent. Then once I get the triangles congruent, I can then use CP-CTC. Remember, you can only use CP-CTC if you have a statement somewhere in your proof before CP-CTC that says triangle whatever is congruent to triangle whatever. So let's go down my proof. The first thing I'm going to do is I'm going to write out the given information. The given information actually gives me two things I need to know. It gives me two angles that are congruent to two other angles in the triangle. So now I can either do angle, angle, side, or angle, side, angle maybe to try to find out if the two triangles are congruent. And I see a side there. BC is congruent to itself by reflexive. So since BC is congruent to itself by reflexive, that actually gives me the third piece of information that I needed, the side. So I have an angle, angle, side, angle, angle, side. I now know that the two triangles are congruent by angle, angle, side. Be very careful when you're writing your triangle congruency statements. Make sure that all your corresponding parts match up. The B had to match up with the C, the K had to match up with the A, and the C had to match up with the B. So it wouldn't be triangle BKC congruent to triangle BAC. It has to be triangle BKC is congruent to triangle CAB. Or I could have said triangle CKB congruent to triangle BAC. So depending on how you write the first congruency, first triangle statement, determines what order the second one needs to be if they're congruent. And the reason for that is angle, side, angle. Now, I have successfully created a triangle congruency statement. Because this green statement exists in my proof, I am now allowed to use CP-CTC as a reason. Until I have a triangle congruency statement, I cannot use CP-CTC as a reason. Okay? So here we go. I'm going to finish out this proof by saying the two sides, these are the yellow sides now, side KB is congruent to side AC, and what's the reason? CP-CTC, corresponding parts of congruent triangles are congruent. Does that make sense? Yes. I believe it is. All right, so what I want you guys to do right now is I want you on your own to go ahead and do the following proof. Given that BA is congruent to DA, CA is congruent to EA, I want you to prove that angle C is congruent to angle E. Hint, you'll probably want to prove the triangle's congruent first. I would draw the picture and write out all this statement. So go ahead and give that a shot, and then we'll look at the answer when you get done. All right, so hopefully you were able to complete this proof. Let's see how it went. The first thing, of course, I do is I write down the given information. I notice the given information has already given me two things that I need to know to prove the two triangles congruent. Now, after I have the given information, the third thing I need is the included angle. That'll give me the triangles congruent by side, angle, side. So I say angle CAB is congruent to angle EAD by vertical angles are congruent. So once you say it, you can go ahead and mark it on the drawing. So that's what I'm going to do. So I'm going to go ahead and mark it on the drawing. And now that the vertical angles are congruent, we can see that the two triangles are congruent by side angle side. So once we've made this statement right here, that two triangles are congruent, we can now use CP/CTC to talk about any of the other corresponding parts. And that's exactly what I'm going to do. I'm going to say that angle C is congruent to angle E by CP/CTC. See how this stuff works? So this is like that problem I had you do at the very beginning of class. You went and proved the two triangles congruent, and once you knew the triangles were congruent, you could say the parts were congruent by CP/CTC. So now that example that we did it in class makes a whole lot more sense, doesn't it?
So I don't get why they put angle CAB, and then the next one they put triangle CAB.
Well, first I'm claiming that the angles are congruent, and you need to know that the angles are congruent before you can say the triangles are congruent. Does that make sense? So I had to have three pieces of information. This was the third piece. All right, let's try this one right here. Let's prove that angle AMB is congruent to angle AMC. So in the picture, that would be this top angle congruent to this bottom angle. Prove that, starting out with this given information. All right, so hopefully you had enough time to complete this proof. Let's see what it is. So the first thing, of course, I'm going to write is given information. As I write the given information, I notice that I already have one piece of information about how to prove two triangles congruent. And that was kind of the hint I gave you, is that you're trying to prove triangles congruent. So I've got one side congruent to another side. The thing that really kind of jumps out at me is that we had something called a midpoint in my given information. And so I'm going to extend that piece of information by making a statement that advances my desire to prove the two triangles congruent. I'm going to say that line BM is congruent to line MC. Now the reason I'm able to say line BM is congruent to MC is because I knew that M was a midpoint, and that's what a midpoint does, is it divides a line into two congruent parts. So BM congruent to MC, the reason for that definition of a midpoint. Then finally, the third thing that kind of jumps out at me is the fact that center line right there is shared by both triangles. I can say a line is congruent to itself by the reflexive property, and I now have three pieces of information. I have three sides of one triangle congruent to three sides of another triangle. So I can now say that the two triangles are congruent by side, side, side. Did everybody follow me on that? Once I've made a statement about triangles being congruent, that opens up the door for another reason, CP/CTC. So I can now say that triangle AMB, the top angle, is congruent to triangle AMC, the bottom angle, and the reason for that is CP/CTC. So when you're using CP/CTC, when you're trying to find additional parts in triangles congruent to each other, the first thing you want to do is prove the two triangles congruent, and then you want to go through and use CP/CTC as your justification for the additional information that you get. Does anybody have any questions about proving corresponding parts of congruent triangles congruent, or this lesson? Yes.
So in the last one, you had put the angles behind it. For number 5, you put angle A.
Mm-hmm. So you're wondering why I didn't make any statements before the triangles about angles. Is that what your question is?
I had to put angle.
Okay. Well, let's look at this problem here. So I'm proving the two triangles congruent by SSS. So does SSS require me to show that any of the angles are congruent? SSS only requires sides. So I have given all the information highlighted in yellow I need for SSS. But if I compare it to this other problem, in this other problem I used SAS. SAS requires an angle. So that's why I have an angle statement here. What angle did you say was congruent in these two triangles? Because you said you wrote an angle statement in here. What was the angle statement that you wrote?
Oh, I had triangle and
What angle did you say was congruent? You said that you put an angle statement up here. I thought that's what you said. Maybe I misunderstood. Okay. So do you understand why I don't need an angle statement up here? Okay. So finally, I made a huge adjustment to the homework for tonight. I've also uploaded that document to Edmodo that changes the pacing for the week. So obviously we're not having class tomorrow, so that's going to change what we do Monday. So here's tonight's homework. Make sure this is the problems you work and not the one from the original pacing guide that I gave you at the beginning of the week. And then tomorrow we won't meet. This homework is due Monday.